Welcome everybody to Pix4D's first webinar, which title is Using the Raycloud. In today's webinar, we're going to talk about the Raycloud, its interface, how to add and edit points, how to measure them together with lines, volumes and surfaces, how to create and export objects, how to optimize the whole reconstruction thanks to the type points, and also how to improve the results in the automosaic and DSM. I'll give now the voice to Christoph Strecher to give an introduction about the concept of the Raycloud.
Hello everybody, my name is Christoph Strecher and I welcome you to the first Pix4D webinar. Today we talk about the Raycloud. What is the Raycloud? Everybody knows point clouds. Point clouds are used, as you can see here, in CAD software to annotate, measure, vectorize 3D data. So this is what you can do in this interface as well. You can use, for instance, this editor to vectorize this building in 3D purely based on point clouds in a CAD-like functionality. Because Pix4D Mapper generates these point clouds by photogrammetry purely based on images, so here on top you see the images that have been used to generate these point clouds, we are able to connect the 3D points with the images. So we are not talking anymore just about point clouds, but about ray clouds. So here you can see the rays that connect a particular 3D point with the camera centers. The intersection of these rays with the images is shown on the right, and you can see here that this point has been extracted from these green positions here in the images. So with this editor we have now a nice ability to annotate 3D points in a CAD-like manner in 3D, and at the same time to measure these same 3D points in 2D in a more photogrammetric approach. So this is kind of a nice connection between 3D and 2D, which combines CAD and photogrammetry approaches. This is the first important point. Secondly, once you have measured 3D structures in 2D by measuring points in the individual images, this information can be used as manual type points or ground control points to also refine the positions of the camera centers or the internal parameters of the camera. So this refinement is called bundle adjustment, that you can do with these measurements in 2D that you have been putting in with this editor. So you have in this way full control over your project. You can introduce very nicely ground control points or manual type points in order to get a better accuracy on the camera centers. For this we are using here a strictly multi-ray approach. So we are not only using 2D images as in traditional photogrammetry to estimate the 3D location of a certain point, but we are using all available images with this in this editor. Why is this important? This is what I show you in these slides. In traditional photogrammetry software, 3D points are estimated based on stereo. There is a stereo display and the user is able to move a virtual plane towards the scene until the two images that are projected onto that plane get into correspondence. If this is the case, then the 3D point of that plane can be read out and used as a 3D measurement of this particular pixel. So what is the error that we make with this approach? The error obviously depends on the baseline of the images, which is the distance of the two camera centers. If this distance is small, meaning that the rays are almost parallel, then the error is in the direction of our rays quite large, which is here displayed by this red arrow ellipsoid. With the Raycloud editor, we are using a strictly multi-ray approach to tackle this problem. Here you can see the situation based on 3 images. If you have 3 images which are much further away in a wide baseline condition where the camera centers are more apart from each other, then this intersection of all these rays is much more well defined, and the error that we make is a lot smaller than in a small baseline condition. So now I give over to Olivier, who will go in more detail about the different aspects of the Raycloud.
Thank you. Okay, let's start by opening Pix4D Mapper. There we are. To start using the Raycloud, you need an already processed project. To do that, you can follow the guide of the Getting Started manual on our website on how to process your first project. To save a bit time, I'm just going to open an already processed project that we can see in this case. You can see that it has been already processed, as the local processing tabs are all in green and not in red. If this is the case, you can then click on the Raycloud editor icon, which is on the top menu there. As Christophe explained, the middle panel represents the 3D view of the point clouds together with many different elements. To navigate inside of this view, you can use the middle button of the mouse and then drag the mouse to move around. If you're using a laptop, then you can actually use the Shift key as well as clicking to rotate the project. To pan, you simply need to click on the left mouse and then drag along the project. To zoom, you can use the scroll wheel of the mouse, or you can use the 2-finger gesture on your touchpad if you're using a laptop. On the top menu, you can see a few more icons to help you navigating in your 3D point cloud, such as the zoom, a possibility to have everything in view, focus that will select on the points that you have selected, and a top view to see the project from above. So these are the main controls of the 3D view panel. Now, on the left, there's a sidebar with multiple layers. You can switch them on and off to display the different elements. You can visualize individually the cameras, the automatic tie points, the densified point cloud. Each of these items have properties that you can edit. For instance, the cameras can have a different size by simply using this slider. The point cloud can also be edited by changing the size of the point. For the cameras, the blue points represents the geotag associated with each original images. This is usually the GPS tag that was recorded by your UAV when you did a flight. The green dot represents the optimized position computed by Pix4D mapper. This optimization is computed based on the image content and as well the ground control points if you have inserted any. The green pyramid represents the geometry of the camera, the shape, basically the focal length as well as the computed and optimized orientation. The Raycloud editor is much more than just a simple 3D viewer. It's a true connection between the computed 3D point cloud as well as with the original images. Let's see that in action. You can click on any point inside of the 3D Raycloud and you will get immediately access to all of the images which made this 3D point possible. In this view you can clearly see the rays and basically the reason why it's called the Raycloud. The rays that are going from the images in which this item is visible to triangulate into a 3D point. By moving the mouse across all the different images from the different view angle, you can see a small purple line appearing in the Raycloud. This indicates the exact particular line and then images that made the generation of this 3D point. To have a closer view of the image, you can use the scroll wheel of the mouse to zoom inside of a specific image. If you need to, the other way to zoom inside of the images is to use the two little icons there, which is going to zoom simultaneously all the images from the different view angles. You can also change the thumb size, the image size, using this slider to display more images at the same time from all the different view angles. This connection between the original images and the point cloud allows really a much better and greater understanding of your data than simply a point cloud. Let's take, for example, this green these green points. One could guess what it could be, but it could be also simply an artifact. Thanks to the Raycloud, you can click on one of its points and thanks to the complexity and all the data which is in the image, you can truly understand that this is not an artifact. This is indeed a little tree which is on top of the cliff of this quarry. As there are many types of different points in which are considered by the Raycloud, I'm going to quickly summarize which are the different type of points that exist and what are their specific properties. To start with, I'm going to show you the automatic tie points. These tie points are computed automatically by detecting key points and matching them in the images to make automatic tie points. This is done during the first step of the processing. This is extremely important as they are the ones that are used for the calibration and the optimization of the whole project. This is really what's going to lead the accuracy both on a local and a global scale of the project. By clicking on a tie point, you can visualize in the images the content of the tie point, and every time there is an orange circle in the image, this means that the tie point was correctly detected and matched in these images. In this particular example, you can see that this tie point is visible in 37 images and has been successfully matched and detected in 11 images. You can also have manual tie points. These manual tie points are created by the user, which I'm going to explain in a few minutes really in details how to do it. And basically it's the users that creates one match between several images to create a 3D point. The manual tie points are also used during the calibration and the optimization of the camera. And this can really help also improving the accuracy of your project, which I'm going to explain later on in more details. A specific type of tie points are 3D ground control points or checkpoints. This is a topic which really relates about measuring accuracy and ground control points and geolocation, and this will be the topic of next month's seminar, which will be dedicated to ground control points, how to collect them, how to add them in Pix4D Mapper, how to add them and how many you need to get the best accuracy and the best practices. By default, when you open Pix4D Mapper, you will see the densified point clouds. By unchecking densified point cloud, you will then only see the automatic tie points. And as I showed you before, by clicking on them, you can visualize them in the original images. On the top panel, you also get a sense of accuracy with several measurements which are explained in the manual. Another way to visualize the tie points is by clicking on a camera. This opens the image view panel with a different window, and you can see the original images with orange little cross overlaid on it. Each little cross is one individual computed and detected tie point. By clicking on it, you can see the reprojection in all of the images. You can note that in this image, the tie points are very well spread across the whole image. This usually is a very good sign of accuracy, and this is what should be expected. On the right, you have a slider that allows you to filter by the amount of matches each tie points have been matched in the different images. The more images a tie point has been matched in, the stronger and the more important it is during the calibration. In this example, you can see that many tie points have been found and detected in more than 20 images, which really give a good sense that this project is very accurately calibrated and processed. Now, how can the Raycloud editor be used to measure points? The first way and the most simple way is to enable the densified point cloud. In this view, as we showed before, you can click on any single 3D point. As you clicked, you can validate in the images that this point is exactly the one that you wanted to click. And as well, on the bottom right of the screen, you get the coordinates of that point. However, one very common problem in measuring points in point cloud is which is the right point to select? Which is the one that makes the most sense? In this example, this is the building edge, the edge of a building. Which is the exact type point, 3D point that needs to be selected to measure it, to get really the points on the building edge? Could it be this one or this one? The Raycloud helps you to select by showing you the reprojection in the image as a little green cross of this 3D point. In addition, the Raycloud editor allows you to add your own measurements in the images to regenerate very accurately 3D points. This is done by clicking the icon on the top of the images called New Type Point. As you click, you are now in the New Type Point mode. By selecting the right pixel in the image and in a second one, this will indeed generate a 3D point which is located exactly on the right edge of the roof. And that's where you can go now even beyond in terms of accuracy than what's just possible with a simple point cloud. By zooming very closely in the images, you can see that you could possibly improve by a few more pixels the measurement. As Christoph explained in the introduction, the more baseline, the more images you do your measurements, the best accuracy you can obtain. For example, I can see that the reprojection, the little green cross, is maybe 2 pixels away from the real corner of the house in this example. By adding one more measurement here, I will improve the triangulation and thus improve the accuracy. By applying my change, I will see my cross, my measurement cross, change little bit in 3D space and be at a place which is even more accurate than before. And this is really the true location of this point in the model. As soon as you have clicked in 2 images, you will see the live reprojection as a little green cross in the other images. And depending on the zoom level at which you have clicked the 3D point, the 2D point, this measurement will have more or less influence in making the measurement. For example, if one image is a bit blurry and you don't trust much the measurement in this image, you can do it, and you should do it, at a lower zoom level to give less weight, less importance to this measurement. To help you detecting the right and clicking on the right object in the images, you can use the Optimize button. By clicking on Optimize, the software will look at the visual content of the images, we'll do some correlation, and we'll try to find matches in additional images by itself. In this case, by clicking Optimize, the software has made lots of measurements in all the different images to improve the triangulation. By clicking on Apply, this now can be really certain to be a very good measurement of the edge of this roof. This is for a single point, but using the Raycloud editor, you can extend the type of measurements you can do also to polylines, lines and polylines. To do so, you need to click on the icon on the top, create a new polyline object. You are now in the polyline editing mode. You can click with the left click mouse, points in the 3D model. You stop your line by using the right click of your mouse. On the top panel, you can see the measurement, the estimation of the length in 3D and in a project 2D mode. In this case, my line measures 30.6 meters. You can also refine the vertices, the position, the location, and the position of each vertices and the endpoint of your line by clicking on them. This will open the Raycloud image view, in which you can refine for every vertices the exact position using the same technique as for the tie points. By moving my vertex in one image and then moving it in the other image, this will modify the 3D position to triangulate exactly at this spot, and by clicking Apply, this will generate the new location of the end of the polyline. By doing a triangulation, you will always have a little bit of error. This error is measured and quantified on the top panel and lets you know how well did the clicking in the different image happen. To reduce this uncertainty, you can go in additional images, and by adding more measurements, improve the accuracy of your line measurement. In addition to line, you can also use surface. To do so, you need to click on the Create a New Surface Object on the top panel. You then select multiple points, and you end up the measurements by clicking on the right button. Again, in this case, you can refine your measurement by zooming in the images and adjusting the corners to be exactly on the image content. This allows you really to go for pixel accuracy measurements of lines, points, and also surfaces. If you have more than 3 vertices in your surface, this surface will be triangulated and then a plane will be fitted to each triangle. Using the surface object, you will be able to measure the length as well as the enclosed 3D and 2D area. By doing the adjustment of the vertices, you can refine the inaccuracy and get better results which are really fitted to your data, as well as making very good accurate measurements. Finally, volumes can also be measured. To do so, you can select the icon on the top menu, create a new stockpile object. You define the base layer by clicking around the objects you'd like to measure the volume. You finish your measurement by using the right click on the mouse. In this area that we just defined, there will be a local DSM computed from the filtered point cloud that you can visualize now in red. On the top right, you will see some accuracy measurement about this volume, such as the cut volume, which is basically the volume which is above the plane that you just defined in green, and the fill volume, which is everything which is below the plane that you just defined. In the case of volumes, we also do measurements of inaccuracy, and these measurements will be depending on the ground sampling distance as well as the size and characteristics of the volume you're trying to assess. To get better volume estimation, the main recommendation is to use a dataset with a higher ground sampling distance. In the images, you can also refine the plane vertices by adjusting them as the points, the lines, and the areas in the images. Never forget to click Apply when you do a modification, otherwise your modification will not be taken in account. I will show you now a few different examples on how this tool can be used in other different settings. In this example, you can see that this tool is used to measure the length of a satellite dish on top of a house. This really shows one of the true power of the Raycloud editor. It allows you to measure objects, distances, even for details which are extremely small and cannot be correctly rendered in 3D. To do so, you create a line, and then in the images you refine to make it really nicely match the middle of the dish and the end of the satellite stick. This dataset is very nice as there are many different angles of view, which helps, as shown in the introduction, to really pinpoint the accuracy as it's seen in this example where after doing a few measurements, the line is perfectly aligned on the satellite dish. On the top panel, you can see that the measurement is computed as being 60 centimeter with 1 centimeter inaccuracy. And for knowing perfectly this house, I can tell you that this is indeed the real size of this satellite dish. Another example on how to use how the Raycloud can be used for different types of projects is to measure the area of the solar panel which are on top of this house. To do so, you select the area tool, and then you click to define nicely the area which you need to measure the area. As soon as this is done, you can see the first measurements on the top right view in the image view panel. And you can visualize if your area is well defined in the project. To get an even extra layer of accuracy, you can go back in the images and refine the position to truly match on a pixel level the position of the solar panels. As soon as you do the measurement in a second image, the 3D points, the 3D vertices of your area will be recomputed and refined, allowing you to get a better estimate of your area of solar panels. Another example is about the possibility to digitize and to measure power lines in a landscape. Power lines are very, very small, thin structure. And in this project, you can almost see the shadow of these power lines and not the real towers and line by themselves. However, in the images, when you click on this point, you can see that there is a tower, that there is a pole which exists. Well, thanks to the Raycloud and the line editing tool, you can create a fake line on the ground and then adjust the vertex which is not on the top of the pole to make it exactly fit the top of the pole. Doing so in 2 images will result in the retriangulation of the top of the pole and thus the measurements and the real 3D position of this power line. As soon as you click apply, the true length of this pole will be adjusted in the view. Now you can simply repeat this process for the different type of poles that is in this project. And very quickly allows you to model objects which are too small but which are present in your data to be reconstructed in 3D automatically, but you still have access to them and you can still fully measure them. So in this example, I click one which I think is on the bottom of the pole, the other on the top of the pole. To finally have the real measurement there. Finally, you can even connect these 2 poles to simulate the effect of electrical line in this project. So I move forward a bit forward to see a project where I've done more measurements. And the very nice thing is that you can indeed use them in Pix4D Mapper, but all of these objects can be seamlessly exported in multiple formats. For example, you can export them in AutoCAD DXF format, as well as in ArcGIS format, in Google Earth format, and in MicroStation format. In this example, I exported my measurements done in Pix4D Mapper and opened them as well as the point cloud into AutoCAD. Using this technique, you can really go much further into what you can extract from your aerial data. Use Pix4D Mapper to do the measurements and the digitization in an extremely nice interface as you get both the 3D point cloud and the images. And then export everything in your existing workflow to continue using the way you use your workflow. Up. The Raycloud, another very nice feature of the Raycloud is that it allows you to increase the global accuracy of your project. Not only for a single measurement, like I just shown in the last examples, but also in the whole global project. In this example, this was a data set which was taken using a camera around an object. And you can see that on the top right of this project, there is a link missing. However, I know that when I took the images, I was exactly at the same position at that point. What happened is that there was some error drift which made the loop closure difficult, and the error made that the images were not matching at the end. How does it look like? When you click on a tie point in this project, you will see that despite doing the measurements in all the images, the green cross, which represents the reprojection of the tie point in the images, is very, very far away from your measurement. In this case, this indicates that there was an error during the calibration and that the calibration is not optimal. The good news is that you can use the button called Reprocess in Pix4D, which is on the top menu there. And by adding a few tie points manually and by doing the measurements, this will be taken in account during the reprocessing. And as you can see in this example, I've added 4 manual tie points in the area which was problematic. And by reprocessing the project, the loop is now fully closed, and when looking again at the tie point in this specific location, the green cross is now perfectly fitted next to my measurements. So to summarize, this the benefit is that by visualizing the tie point, you can first assess if the reprojection is good and is at the right spot, which means that the calibration is very likely to be good and helps you to detect areas where you can visually see that the tie points are not matching. In addition, it allows you to add your own manual tie points, which are taken in account when you're doing a re-optimization to really adjust and take your measurements to resolve the ambiguities that happen during the processing. Another topic on which you can use the Raycloud to improve your results is by using the surface area tool, the same that is used to compute the area, an area of a place. In this example, we can visualize the digital elevation model of a house. You can see that on the edge, there is a bit of noise due to low image quality and also noise in the measurements. This reflects that when generating the automosaic, you can see that there is noise and small artifacts on the building, on the edges of the building. Thanks to the Raycloud, you can use the surface tool to make the contour of your house. In this example, you can see that there was a surface drawn on top of the house and another one on the bottom of the house. And when you regenerate the elevation model, you can see that now the noise is gone and there is very sharp edges around the building. This means that when the mosaic is then automatically generated after this step, the edges are also perfectly straight and there is no more artifacts around the building edge. So this is the other way that the Raycloud editor can help you improving the quality of also the mosaic. So this is basically concluding the first introduction to the Raycloud. I hope that this allowed you to get an understanding of the possibilities and also to really master this tool that helps you to go much beyond what's possible to do in point clouds, measurements, and accuracy validation of image processing, photogrammetry image processing. I'll take also the opportunity to introduce our next webinars and workshop. We have workshops 2 days and 1 day in July that will be hosted in Switzerland. One which is really about gaining a general understanding and hands-on experience, and the other one which is really a much more advanced, in-depth training by our in-house specialists. As I mentioned before, the next webinar will be around ground control points, how to efficiently insert them in Pix4D Mapper, how to assess the accuracy of them, and what are the best practices. You can directly go on our website and sign up for both the workshops and the webinar. Also, don't forget that you can always get a 1-week trial of Pix4D Mapper for free by simply going on www.pix4d.com/buy_rent or by simply clicking on the buy or rent button in our website. This video will be available for download in our support webpage, also with all the datasets that we have shown. I'd like also to mention that our support team is always available for any type of questions, and that you can contact us simply at support@pix4d.com, and that we have a very extensive knowledge base where you can get additional content about how to use Pix4D Mapper and most of the topics that I've been presenting today on support.pix4d.com. With that, we're finishing right on time. I'd like to thank you all for attending this webinar, and I wish you a very pleasant day and hope to see you for the next one.